Hoping you're doing good. Welcome in today's tutorial. My name is Michael Regan, and in today's agenda we want to look at what data is, types of data collection methods, ethics and privacy in data science and analytics. Is the last thing that we will deal with in this tutorial. Data is critical in research and decision making, as it provides information that can be used to support arguments, test hypotheses, and make informed decisions. And data refers to the raw information that is collected, stored, and analyzed to extract insights and make informed decisions. Data can be in many forms. It can be numerical data, it can be categorical data, ordinal data, or even text data, for example, words and sentences. Remember, data is the backbone of many industries, including technology, finance, and marketing. And by analyzing data, organizations can make informed decisions, identify patterns and trends, and improve their operations. Data is a fundamental aspect of many fields and is central to many decision-making processes. Therefore, understanding data and its characteristics, as well as its collection, storage, analysis, and privacy, is essential for success in today's data-driven world. There are two main types of data, that is quantitative and qualitative. And quantitative data is numerical data that can be analyzed using statistical methods. It includes data such as age, height, weight, and income. Qualitative data is descriptive and non-numerical data. It includes data such as opinions, attitudes, and beliefs. So let's look at these two types of data and their subcategories. Like I had said earlier, quantitative data is numerical data that can be analyzed using statistical methods. It is objective and can be easily measured and compared. Examples of quantitative data include age, height, weight, income, test scores, and product sales, just to mention a few. It is often used to measure or describe a quantitative or continuous phenomenon. It can be further subdivided into the following: one being a discrete data. And discrete data is data that can only take on a limited number of values, such as the number of children in a household or the number of times a patient or a person has visited a doctor. Continuous data. And continuous data is data that can take on any value within a given range, such as height, weight, or temperature. Ordinal data. Ordinal data is data that can be ranked or ordered, but does not have a meaningful numerical value, such as levels of education. Interval data. Interval data is numerical data that has a defined 0 point, but does not have a meaningful absolute value, such as temperature measured in degrees Celsius. Ratio data. Ratio data is numerical data that has a defined 0 point and a meaningful absolute value, such as height measured in meters or weight measured in kilograms. Qualitative data is descriptive and non-numerical data. It provides a more in-depth understanding of attitudes, behaviors, and experiences. Qualitative data is often collected through methods such as interviews, focus groups, and observations, and used to describe the qualities or characteristics of a phenomenon. Examples of qualitative data include opinions, attitudes, beliefs, and motivations. It can be further divided into one, nominal data. Nominal data is data that can only be categorized into non-ordered categories, such as gender, hair color, or eye color. Categorical data. This type of data is characterized by categories or grouping, such as demographic information or opinions. Descriptive. And this type of data provides detailed information about the characteristics or attributes of phenomena. Textual data. And textual data is collected through written material such as written accounts, journals, or notes. Narrative. And narrative data is collected in the form of stories, personal accounts, or descriptions describing a given phenomena in that case. And to finish with qualitative data, we have verbal data, and this type of data is collected through verbal communication such as interviews, focus groups, or observation. Now, the type of data you collect will depend on the research question and the purpose of the study. Understanding the different types of data will help you choose the appropriate method for collecting and analyzing the data, leading to more accurate and reliable results. So now that we've talked about data, we know what data is, we know what are the different types of data. Now when we need this data, how can we collect them? So we want to look at different data collection methods. And data collection is the process of gathering information for the purpose of analysis and decision making. There are several methods for collecting data in data science analytics, including the following that we want to look into. Surveys being the first one. And surveys are a way to gather data by asking questions to a large number of people. Surveys and questionnaires have been in use for a long period of time and have been providing meaningful information in data science and analytics. And to conduct a survey, you will need to design a set of questions to ask your participants. The questions should be clear, concise, and relevant to the information you are trying to gather. Surveys can be administered in a variety of ways, including online, by phone, by email, or even in person. Advantages of surveys and questionnaires include that they can be administered to a large number of participants, they can be tailored to specific populations, and they can be conducted relatively quickly and inexpensively. Disadvantages include that they may be subject to response bias, where participants may not answer truthfully, and that participants may not have enough knowledge or experience to accurately respond to certain questions. Second, we have experiments, and experiments are a way to gather data by manipulating variables and measuring the effects of this manipulation on a particular outcome. Experiments are a powerful method for collecting data in data science and analytics, as they allow researchers to manipulate variables and observe the effect on a dependent variable. To conduct an experiment, you will need to define a clear research question, choose a suitable sample, manipulate one or more independent variables, and measure the dependent variable. Experiments can be conducted in a variety of settings, including laboratory settings, online, or even in the field. Advantages of experiments include that they allow researchers to establish causality. They can be controlled to minimize extraneous variables, and they can provide accurate and precise data. Disadvantages of experiments include that they can be time-consuming and expensive. They may not be representative of real-world settings, and they may be subject to ethical consideration, such as when conducting experiments with human participants. In that case, it will be subject to ethical considerations. Observations being the next one, and observational studies are a method of collecting data by observing and recording data without manipulating any variable. To conduct an observational study, you will need to choose a suitable sample, design a data collection protocol, and collect data on the variables of interest. Observational studies can be conducted in a variety of settings, including naturalistic observations, field studies, and case studies. Advantages of observational studies include that they can provide real-world data, they can be conducted relatively quickly and inexpensively, and they may be more representative of real-world settings than experiments. Disadvantages of observational studies include that they may not establish causality, they may be subject to selection bias, and they may be less controlled than experiments. Next, we have secondary data, and secondary data refers to data that was collected by someone else and for a different purpose. Secondary data can be obtained from a variety of sources, including government agencies, research institutions, and private organizations. Advantages include that it can be obtained quickly and inexpensively. It may be comprehensive and up to date, and it can be used to support or refute existing theories. Disadvantages include that it may not be relevant to the specific research question. So in that case, you may find secondary data which is not related probably to the research question. It may be subject to bias or error, and it may not be accessible to all researchers. Next, we have web scraping, and web scraping is a method of automatically extracting data from websites using software. This method is useful for collecting data from websites that do not provide an API or other means of accessing their data directly. Web scraping can be performed using various programming languages and libraries such as Python and Beautiful Soup. Advantages of web scraping include that it can collect large amounts of data quickly, it can access data that will otherwise be difficult to obtain, and it can automate the process of collecting data. Disadvantage is that it may violate the terms of use of the website being scrapped. It may be technically challenging, and it may require significant computing resources. APIs is the next thing, the application programming interfaces. And APIs are a way for software application to communicate with each other and share data. APIs allow data to be accessed programmatically rather than manually downloading it from a website or other source. Many websites and online services provide APIs that allow developers to access their data and functionality. Advantages of APIs include that they can provide access to real-time data, they can automate the process of collecting data, and they can allow for fine-grained control over the data that is collected. Disadvantages is that they may have usage limits, they may require technical skills to use, and they may not provide access to all the data that is available on the website or service. Sensors. Sensors are devices that collect data by measuring physical quantities such as temperature, light, sound, or movement. Sensors can be used in a variety of settings, including environmental monitoring, industrial process control, and medical devices. Advantages of sensors is that they can collect real-time data, They can provide accurate and precise measurements, and they can be used in a variety of settings. Disadvantages is that they may require specialized technical skills to use. They may be subject to interference or other sources of error, and they may require significant computational resources to process and analyze the data that is collected. Social media. Social media refers to websites and online services that allow users to share content and communicate with each other. Social media can be a valuable source of data for data science analytics, as it provides access to large amounts of information about people's opinions, behavior, and interactions. Social media data can be collected through APIs, web scraping, or manual methods such as manual data entry or data collection via surveys. Advantages of collecting data from social media include that it can provide access to real-time data. It can be a rich source of information about people's behavior and opinions, and it can be used to study social and cultural trends. Disadvantages is that social media Disadvantages of collecting data from social media is that the data may be subject to bias. For instance, it may be difficult to verify the accuracy of the data, and it may raise privacy and ethical concerns. So guys, these are just a few of the main data collection methods available. Remember, the method you choose will depend on your research question, the type of data you are collecting, and the resources available to you. Understanding the different data collection methods and their strength and limitation will help you choose the best approach for your study. Data is very important, and when dealing with data, there are ethics and privacy measures that data scientists and analysts should put into practice. Now let's look into the importance of ethics and privacy in data science analytics, and how to ensure that your work aligns with ethical principles and protects the privacy of individuals. So ethics refers to moral principles and values that govern the behavior of individuals and organizations. But now, in the field of data science and analytics, ethics is about using data and technology in a responsible and equitable manner that benefits society as a whole. There are ethical concerns brought about by data science and analytics, and in this case, data can contain bias and discriminatory patterns that can be perpetuated in the analysis and decision making. Remember, it is in the decision making process. Data can contain sensitive information about individuals, and the misuse of this data can have serious consequences for their privacy and security. Data scientists and analysts have a responsibility to ensure that their work is transparent, accurate, and accountable. Now, to ensure that there is ethics, data scientists and analysts should therefore regularly evaluate their work to ensure that it is aligned with the ethical principles and values. Consider the potential impact of their work on individuals, communities, and society as a whole. Besides engaging with stakeholders, including data subjects, data regulators, and relevant experts, to understand their perspective and ensure that their work is responsive to their needs and concerns. Privacy. Remember, we're talking about ethics and privacy. Now, privacy refers to the right of individuals to control their personal information and to prevent unauthorized access, use, disclosure, or destruction of that information. Similar to ethics, there are privacy concerns in data science analytics, That is, data can be collected from individuals without their knowledge or consent, which can compromise their privacy. Data can be stored and shared in ways that compromise the privacy of individuals. And data can be used and analyzed in ways that compromise the privacy of individuals, for example, by revealing sensitive information about their personal lives. Now, as a way of ensuring privacy of data, as a data scientist, regularly assess the privacy impact of your work to identify and mitigate privacy risks. Use privacy preserving techniques such as data anonymization and differential privacy to protect the privacy of individuals. And lastly, obtain the informed consent of individuals for the collection, storage, use, and sharing of their data. So ethics and privacy are important considerations in data science analytics. By following best practices and engaging with stakeholders, data scientists and analysts can ensure that their work aligns with ethical principles and protects the privacy of individuals. So guys, thanks. That's all for today. If you have any questions,